This is a rational equation example. It's going to get a little ugly, so hope you're ready. The first fraction, as you look at it, we notice what the denominator is. It's an e plus 5. That means immediately all of these fractions are going to need to be multiplied by e plus 5. So I'm going to go ahead and do that. E plus 5 times this e on top. But what's going to end up happening is that since they have the same thing on the top and the bottom, they'll eliminate each other. Unfortunately, everything else needs to get multiplied by that too, and we're not so lucky with cancellations like that one. E plus 5 gets to that fraction. This fraction also gets an e plus 5, but you'll notice here we have the same thing, e plus 5 and e plus 5. So we kind of helped each other. We helped that fraction out as well. The next fraction, as we go to the right, we see that it has an e minus 5 on the bottom. So we're going to need to multiply everything, each fraction, by an e minus 5. This one, nothing happens. It doesn't cancel out. It's just stuck on the top. And it's a problem for in another minute. Then we have e minus 5 right here. This one, this fraction is the reason why we used e minus 5 to get rid of the bottom, and it will cancel out. This one also gets an e minus 5, and fortunately there is an e minus 5 on the bottom, so that one's gone too. Okay, so now we just kind of got to reassess what we got. We have e times e minus 5 from this fraction right here. And we're going to distribute that in a second. We would end up getting e squared minus 5e. Okay, but that's just the first fraction. Second fraction, we would have 5 times e plus 5. And this would need to get distributed as well. So we still have the equal sign over here. We still got stuff to deal with. And this would get distributed as well. And we'd get plus 5e plus 25. On the other side, all of the stuff canceled. We did multiply this top by an e plus 5 and an e minus 5, but they both canceled out with the things on the bottom because they were the same item. So now we have 2e minus 24 left over there. All of the denominators are gone. That's kind of the whole goal of solving rational equations. Get rid of the denominator so we can just use algebra. So we can also see here, if we just added like terms, I mean, we're going to have a quadratic here. It's an e squared. So we're going to have to, dealing with the quadratic means we have to get everything to one side eventually, set it equal to 0, and try and use the methods we've learned before. So anyway, we can add some like terms here, negative 5e and positive 5e. That will make just straight up 0, which is just 0. We do need to get this stuff to the other side with the e squared. So we can set it equal to 0 and solve the quadratic. So I'm going to subtract 2e. We'll have to subtract 2e over here. And I'm going to kind of try to do this all in one step. I'm also going to have to get this 24. It was a plus, not a minus. A positive 24. I'm going to have to get that out of there. So I'll put a negative 24 with it. So now I have e squared minus 2e minus 24 plus 25. These are like terms. They're going to get combined and turn into a 1. So we would have e squared minus 2e, it's a bad 2, plus 1 equals 0. And now the reason why this unit's difficult is because we have to use a lot of the stuff we learned before from the quadratics unit. This is it's a trinomial and it's factorable. When we factor these things, these quadratics, we think of what two numbers multiply to be the third term. So the only thing that you're going to get by multiplying to end up with 1 is 1 times 1. But they have to add to be a negative 2. So we can't use positive 1, positive 1. It has to add to be a negative 2. So it'd be negative 1 and negative 1. So this is factoring. And we know what this e minus 1 and e minus 1 is equal to 0. And then to finish this off, to solve the quadratic, this is the zero product property. And if this chunk times this chunk is equal to 0, then either of those could be equal to 0. So you'd have e minus 1 equals 0, and e minus 1 equals 0. Obviously, it's the same. And to solve this, you just add 1, like regular algebra. You have the opposite. We have e equals 1. Same thing would happen here. You'd have e equals 1. So in this case, We don't have any extraneous solutions. An extraneous solution would be like maybe if e was equal to 5, because you could tell right here, if e was equal to 5, when you plugged in e, you'd end up with a 0 in the denominator, which is undefined. It can't exist. So if we got 5 for an answer when we did this algebraically like we did, that would be called an extraneous solution, because even though we algebraically worked it out and got that as an answer, it really can't be that, because again, if you plugged it in, you'd get 0 on the bottom, and that does not exist. So we're fine. If we plugged in e, this would work out, or if we plugged in 1 for e, this would all work out.